So picture this. You're navigating this massive, totally unfamiliar airport terminal.
Oh, yeah. Always stressful.
Right, it's chaotic.
Yeah.
But you look up and you see this simple icon of an airplane right next to this bright, high-contrast arrow pointing to the right.
Mm-hmm.
And your brain just registers the instruction instantly. Like departures are that way. You don't even read the words underneath it. You follow the geometry.
Yeah, because we are, we're highly visual creatures. When we see a directional shape like an arrow, our brain basically bypasses our slower, more deliberate language processing centers entirely.
Oh, wow. It just skips it.
Exactly. It goes straight to spatial reasoning. So the comprehension is just immediate. It's fluid.
But imagine if for some reason that arrow was suddenly replaced by a giant glowing dollar sign.
A dollar sign.
Yeah. Or like an asterisk. To
Yeah.
figure out where you needed to walk, you would have to actually stop, stare at this completely abstract symbol, read a dense paragraph of text underneath it, just to understand its specific context in this terminal, and then, mentally translate that abstract rule into a physical direction.
I mean, the cognitive friction there would bring the entire terminal to a grinding halt.
Totally.
You would have these massive human traffic jams simply because people would be standing around trying to literally parse the signage.
And welcome in, everyone. We build those chaotic, asterisk-filled airports all the time in our digital spaces.
We really do.
When we structure complex information, especially in programming or even just, our daily workflows, we constantly rely on these highly abstract symbols. Symbols that force the human brain to do all of the mental heavy lifting.
Yeah, it's exhausting.
Which brings us to our mission for you today. We are looking at a very specific, frankly fascinating snippet from a programming journal.
Right, so we are unpacking a text titled Notes-on-Haskell-Programming, Part 188.
Part 188.
Yeah, written by an author named Ang, and this was published on July 16th, 2026.
You just have to respect the sheer dedication to documenting the daily realities of software development.
Oh, absolutely.
And our goal for you today, as we dig into Ang's notes, is to explore something that sounds microscopic at first, but has massive implications for how we actually process information.
Mm-hmm.
We're going to look at how a single character change in a line of code syntax can fundamentally alter human comprehension.
Just one character.
Exactly. Okay, let's unpack this, because framing this around something as niche as a Haskell code refactoring might sound a little intimidating.
Right.
But it is actually a total masterclass in readability, cognitive load, and visual communication.
What's fascinating here is that this source material strips away all the noise. It focuses purely on the ergonomics of reading.
The ergonomics of reading, I like that.
Yeah, because we are not talking about changing what the code actually does or, making it run faster on the computer's motherboard.
Right, the machine doesn't care.
Exactly. A computer can read a dollar sign just as fast as it can read any other character. It's all the same to the machine. We are talking strictly about how the human eye and the human brain process a complex sequence of logic.
So let's start at the highest level of Ang's blog post before we even look at the structure of the code itself.
Sure.
Ang's primary goal here is improving the readability of their Haskell code.
Right.
And the specific method they're using to achieve this is replacing one operator, specifically the dollar sign symbol, with a different operator from a library called flow.
The slow library.
Yeah. And this new operator is built using a less than sign followed by a vertical pipe.
Okay.
So visually on the screen, it looks exactly like a small triangle pointing to the left.
And the author's underlying reasoning for this swap, it touches on this really profound principle of visual design.
How so?
Well, Ang explicitly states that the new symbol, that left-pointing triangle, visually suggests the direction of the data pipeline.
It points the way.
Exactly. The dollar sign, conversely, is just purely abstract. I mean, it's a shape with historical financial connotations, but in the context of passing data from one place to another.
It has no spatial meaning.
Right. It carries zero inherent spatial meaning.
It makes me think about reading sheet music versus reading a text description of a melody.
Oh, that's a great comparison.
Like, if you hand a professional pianist a piece of sheet music, they don't have to consciously read the words, play a C, then skip up 2 whole steps to an E.
They'd never be able to play at tempo.
Exactly. They see the spatial relationship of the notes on the staff, the physical vertical distance on the page maps directly to the physical distance on the piano keyboard. It's just fluid.
And that maps perfectly to what functional programming languages like Haskell are fundamentally trying to do.
Break that down for us a bit.
Sure. So in procedural programming, you might give the computer a step-by-step list of instructions to change a single piece of data.
Like a recipe.
Right. But in a functional language, you're constructing pipelines. You take raw input, you pass it through a filter, pass that result through a formatter, and then pass that out to the user.
So it's an assembly line.
Yes, it
Okay.
is a continuous assembly line of data transformation.
But if I'm building an assembly line and I use a dollar sign to connect
Yeah.
all those different stations, I mean, I am forcing the human brain to hold an arbitrary rule in its working memory,
Yes,
right?
exactly.
I have to memorize that whenever I see this specific abstract shape, it means I need to evaluate everything on the right side of it first and then pass that result back over to the left.
And doing that consumes a fraction of your working memory. Cognitive psychology tells us a lot about concepts like Miller's Law, which basically states our working memory is severely limited.
It's like, what, 7 items?
Roughly, yeah. Plus or minus 2. We can only hold a handful of items in our active consciousness at any given moment. So if you are burning some of that precious cognitive bandwidth just remembering how to interpret the punctuation, you have less capacity available to understand the complex business logic the code is actually executing.
So every single time my eye hits that dollar sign, I have to run this little mental translation subroutine before I can actually understand the code
You
itself.
have a tiny little speed bump.
But when you replace that dollar sign with an arrow pointing left, that translation step just vanishes entirely.
It does.
Your visual cortex processes the geometry of the arrow pointing from the right to the left before your conscious mind even has to retrieve the syntax rule. The data is moving left. The symbol points left.
The visual shape maps onto the conceptual action. It is an incredibly elegant alignment of form and function.
Aang is very grounded about this, though, which I appreciated.
Yeah, very pragmatic.
The text doesn't present this swap as an instant magic wand that fixes everything the second you type it. Aang starts with a very basic, cautious implementation.
Right.
They note that for a simple replacement,
Yeah.
we won't actually see much improvement.
Because the first example Aang provides is just a single trivial line of code. It's literally just used to import the flow library itself, so this new operator can be utilized in the file.
It's just import flow.
Exactly.
And there is this prevailing mentality in a lot of fast-paced work environments, right? If it ain't broke, don't fix it.
Oh, constantly.
If the code compiles and the application runs, why are we spending billable hours tweaking punctuation?
Yeah.
If I am a skeptical developer on this team, I look at that one-line change and argue it is totally wasted effort. Like, why bother going through the friction of bringing in a whole new external library, adding dependencies to the project, and introducing a new symbol to your team if the isolated impact on a simple line of code is practically negligible?
And that is a very real, very common pushback in engineering teams. Like, is the friction of changing our standard practices actually worth the theoretical payoff?
Right.
But Aang's documentation here demonstrates a highly mature understanding of how systemic design changes actually work. Aang is fully aware that this one-line change is unimpressive.
Right, because if I'm walking across a completely empty room, I don't need a series of brightly colored arrows taped to the floor to help me find the door.
No, you can just see the door.
Exactly. The cognitive load of reading one simple line of code is already near zero.
The friction simply hasn't built up yet. Systemic readability doesn't come from isolated statements.
That makes sense.
Aang is setting up the premise that the real return on investment for this swap only reveals itself when complexity scales up. A single arrow on a blank wall is redundant, but an arrow inside a dense, crowded maze, that's a lifesaver.
And that takes us straight into the maze.
It does.
Since the simple replacement didn't prove the point, Aang provides a very complex before state to truly justify this refactoring.
Let's get into it.
And for you listening, we're not going to read the raw Haskell syntax character by character, because that would just be an audio bowl of alphabet soup.
It would be brutal.
We want to describe the shape and the density of it instead, though we should look at the pieces.
Right, so let's look at what the code is attempting to do conceptually. Aang shows us a function called validate args.
Okay.
And the signature is pretty dense. It takes args and returns an IO action wrapped around an either, which contains an appar on the left or a tuple on the right with args and a byte string.
See, alphabet soup.
Yeah, a bit. And the arguments themselves are destructured too. You've got args bound to an args record, where input path is path, output format is FMT, and tidy is the tidy flag.
Okay, so just imagine this very dense, multi-layered block of text doing a lot of heavy lifting for the application.
Exactly. It is checking if certain file paths exist on the hard drive, It is validating the format of the output, and it is setting up error handling routines if any of those checks fail.
It is checking multiple conditions, one after the other. And in this before state, the connective tissue holding all of these critical, distinct operations together is the $sign.
Right.
The code sets up the main logic block with run except t, and the line ends with a $sign to start a do block.
Okay, that's one.
Then the next line reaches out to the operating system to check if a file exists. It says exists, comes from lift.io, it connects that action with a $sign, and then does file exist path.
That's two?
And the next line evaluates if that check was successful. It says unless exists, another $sign. Here's where it gets really interesting.
Because we end up with a visual structure where 3 consecutive lines of complex critical logic all pivot on the exact same abstract symbol.
If you were visualizing this on a screen, the $signs are practically stacked on top of each other at the end of these commands.
Just a wall of them.
Yeah. As a reader, I'm trying to track the direction of the data. I'm trying to figure out what feeds into what. And every line hits this visual brick wall.
Right.
It feels like having multiple $signs forces the human brain to build a temporary syntax tree in our own heads. We have to manually parse the hierarchy of operations rather than just, seeing the flow.
And that brick wall effect is the core mechanism of cognitive friction here.
Walk us through that.
Let's break down what your brain is physically doing when it hits one of those symbols in the middle of a complex block.
Okay.
When you read a line that says, basically in English, check the file exists, then pass it to the system operation, your eye naturally scans left to right.
Right, like reading a book. I read the first command on the left, and then I hit the $sign.
And the $sign acts as a full stop.
A full stop.
Yes.
Yeah.
It tells your brain to hold that first command in your active memory and stop reading left to right. Now you have to jump to the end of the line, figure out what the right side of the equation is doing, evaluate it, and mentally carry that result backward across the $sign to plug it into the first command.
That is wild when you lay it out like that, because human language is almost entirely linear. Subject, verb, object. I threw the ball. When we introduce an operator that forces right to left evaluation inside a system that we are already reading left to right, we create this massive collision.
A total collision.
It's our natural linguistic instincts crashing into the mathematical logic of the code.
And bridging that disconnect requires raw cognitive horsepower. You are actively, consciously calculating the sequence of events.
You're doing mental gymnastics.
You really are. You are jumping forward, doing the mental math, and then jumping backward to plug the answer in. And you have to do that 3 times in a row, nested inside this one block of code.
Right.
By the time you figure out how to read the sentence, you might have forgotten why you were reading it in the first place.
Which makes the payoff in Ang's post incredibly satisfying.
Oh, yeah.
Having established this mental toll, this completely exhausting before state, Ang reveals the transformation, the after state.
And keep in mind, the underlying business logic remains absolutely identical.
Nothing fundamentally changed about what the program does.
Right. The program is executing the exact same sequence of system checks, but the visual cues are completely swapped out.
So everywhere there was a $sign acting as a brick wall, Ang drops in the new operator from the flow library, that left-pointing triangle.
Yep.
So the run except t line setting up the logic block, it points left. The lift.io line, checking if the file exists, points left. The unless exists line handling the errors, points left.
And the change on the page is striking. The visual evidence immediately backs up Ang's claim that this definitively makes the code more readable.
It just looks better.
It does. By explicitly pointing left, the syntax physically draws the reader's eye backward through the data pipeline.
It makes me think about how our eyes physically move across the screen. We don't read smoothly in one continuous glide, right? Our eyes dart in these little microscopic jumps.
Right, they're called saccades.
Saccades, exactly.
And when you have a directional arrow pointing left, those saccades are guided. The geometry of the symbol acts as a visual track for your eye to follow.
That is so cool.
You aren't just intellectually understanding the flow of data anymore. Your eye is physically tracing the path of the data backward through the pipeline.
The code is finally telling you how to read it.
Exactly.
You no longer have to hit a stop sign, hold a command in memory, jump to the end of the line, and jump back. The visual cue of the arrow shows you, in real time, exactly how the result of the file check feeds directly into the system operation.
It creates a blueprint.
Yes. Like if a plumber looks at a schematic for a commercial building, they don't want to read a dense paragraph describing the water pressure moving from the main valve to the third floor.
That would be a nightmare.
They want to see a continuous line with arrows showing the directional flow of the water. Eng basically took a paragraph of text and turned it into a blueprint.
And doing that shifts the burden of interpretation off of the human reader and places it entirely onto the structural design.
Where it belongs.
Right. Eng recognized that while the code was functioning perfectly for the machine, it was failing ergonomically for the human.
Yeah.
Taking the time to import a library and refactor an entire block of logic just to access a directional arrow is a profound statement about the true bottleneck in modern knowledge work.
Which is,
The bottleneck isn't machine processing power anymore. It is human attention.
oh, wow. That hits hard.
It's the truth.
So what does this all mean for us? Because we've spent this deep dive analyzing a single character swap in a functional programming language.
Sure.
But Eng's Part 188 isn't just a lesson for software engineers writing in Haskell.
Yeah.
It is a broader revelation about how we interact with information every single day.
Oh, absolutely. This principle applies directly to anyone who organizes data, which is essentially everyone listening to this.
Right.
Think about a massive, heavily nested Excel formula. You have if statements inside of velo oops, inside of error handlers. It is just a dense wall of parentheses and commas.
Oh, I've been there. Anyone who has tried to debug a spreadsheet like that knows the exact cognitive friction we are talking about here.
It's painful.
You spend 10 minutes just trying to match the opening parentheses with the closing parentheses before you can even begin to figure out why the math is wrong.
Exactly. And what Eng is teaching us is that we shouldn't settle for that friction.
We don't have to just accept it.
Yeah. No. Whether you are structuring financial models, drafting a multi-phase project proposal, or just trying to organize your personal notes so your future self can understand them, small, intentional visual cues drastically reduce the friction of engaging with your own work.
Using line breaks, indentations, color coding, or, directional arrows in your flowcharts. These aren't just aesthetic choices to make a document look pretty.
Not at all.
They're cognitive offloading techniques.
That's the perfect term for it.
Right. They free up your mental bandwidth so you can focus on the actual problem you are trying to solve, rather than struggling to parse the formatting. You want your notes to guide you, not challenge you.
And we demand that level of intuitive clarity in our physical spaces. Going back to your initial thought, we wouldn't tolerate a sprawling airport terminal without clear directional signage. We expect the environment to guide us.
Yet we just accept the chaos in our digital environments.
We really do.
We build these towering walls of text and abstract symbols and then wonder why we feel deeply fatigued after an hour of reading through a shared document.
It certainly makes you want to audit your own workflows, doesn't it?
Oh, definitely.
To see where you are forcing yourself to do unnecessary mental gymnastics.
Which is exactly the provocative thought I want to leave you with today.
Yeah.
As you go back to your emails, your spreadsheets, your interfaces, think about those friction points.
Find the dollar signs.
Exactly. If changing just one abstract symbol to a simple directional arrow can completely alter a programmer's understanding of a complex logic system.
Yeah.
How much of your daily digital communication is currently being slowed down or misunderstood simply because you're using abstract symbols instead of intuitive visual cues?
A great question.
What dollar signs are hiding in your daily workflows, just waiting to be turned into arrows? Look for the arrows, everyone. Thanks for joining us on this deep dive. We will catch you on the next one.